These are the parts that came in the kit for the Sixth Sense Design Challenge. So over here is the CPU, which is a Nucleo 64 STM32F411, and we can take it out of its package, presumably. Oh, it's snapped right into its package. And there's a picture of the pinout in the case. And this is the sensors package. So the sensor shield. And then there's a little carrier board with a 5-pin connector on it. It looks like it can have a micro SD card as well. It's got a USB port and a switch. And then there's the little sensor shield itself, which is quite small. And some miscellaneous parts. There's mounting screws. There's a little clear case here, which looks like it can hold this carrier card. There's a cable to connect this card to probably this connector over here. Oh, and a little battery. So this thing looks like it can be battery operated. In here we have some sensors. There are 3 of them. This is the load cell. Now, on the data sheet it said that this thing, it only shows that this thing has wires coming off, and it explains what the wires are. But this one doesn't have those wires, and the data sheet doesn't explain what these pins mean. But I think I can just make it out on the silk screen, which is partially obscured by the gasket. So I'll read that with a microscope and let you know what those pinouts are. This little guy is a platinum RTD, I think. A very small temperature sensor. And those wires are minuscule. This little guy, so this is a little magnetic rotation sensor. And I'm going to have to find a way to mount that on a custom printed circuit board so that it can measure rotation in the location that I want. But it's a surface mount part, and the pinout is very difficult to solder with a normal soldering iron. But we'll see what we can do. So this shield is Arduino compatible, as is the main Cortex M4. Looks like it goes this way. So it can sit on this shield here. I'm not plugging it in just yet, but it'll sit on top of the MCU, and it looks like this card connects here through the cable, or it looks like we can also directly solder the sensor package to this tile footprint here. Oh, actually there's a little connector, surface mount connector, that will mate to this, so it can just plug on. That's pretty cool. I'm going to switch to my microscope camera to get a better look at these small sensors. Here's the RTD next to a T1 3/4 LED. Here it is next to a 1/4 watt resistor. Notice how large the 1/4 watt resistor leads are compared to the RTD. Here's the tiny magnetic rotation sensor next to a 1/4 watt resistor lead and an RTD lead. On the underside you can see the close pin spacing and get some idea of how hard it will be to solder this thing. The marks on this ruler are 1 millimeter apart, so the whole package is only just over 2 millimeters. This tiny sensor tile has approximately 14 sensors, plus it has a Cortex M4 MCU and a Bluetooth Low Energy chip. These are some of the parts that I've been purchasing for use in the 6th Sense Design Challenge. In my case, it's a graffiti robot, which is going to use pumps in this reservoir. These are 8 individual aquarium pumps to pump water or paint into the nozzle, which I 3D printed here. Each of these ports is a separate chamber, and the chambers have these very small pores at the output, which can create about a 1-inch path of fluid as this thing is driven along. So each of these will represent sort of a pixel. Each port is a pixel, so there's 8 pixels that can be turned on and off by turning on and off each of these pumps. And those will be the motors will be turned on by these transistors, which I acquired as part of a winning shopping cart from one of the Project 14 contests. So these are large field effect transistors. Okay, I guess I can show you exactly what the tubing is going to look like as well. I've purchased some very flexible tubing, and it will plug on to any of the motors and also onto the port of the nozzle. I've tried this out, and the tube seals well to all these ports, and the water definitely sprays out of the micropores. It still remains to be seen if it's the right amount of water and how I need to control that, but so far so good. I've also purchased some O-rings, which I'm going to use as tires on my 3D printed wheels. So it's a long way from being a complete bomb. I have a lot more stuff to acquire one way or another, or 3D print. But I'm starting to get things together, and it should take shape pretty shortly.